Welcome back to Geometry, Chapter 6, Section 4 in this book. So what we've been talking about is parallelograms. That if these two sides are parallel to each other, those two sides are parallel to each other. And we've been learning facts about parallelograms and ways to prove it. Now we're going to talk about some special parallelograms. All are parallelograms that are rhombuses, rectangles, and squares, which for some reason that's triggering a memory in my head of some song in the 60s. I can't remember what it is, but it's like on the edge of my brain. I think it's the one about rosemary, sage, and thyme or something. Rhombuses, rectangle, and squares. Anyway, so what is a rhombus? A rhombus is a quadrilateral that has four congruent sides. That is a terrible drawing, but if you just imagine a diamond where all four sides are the same length, that's a rhombus. A rectangle is a quadrilateral where all four angles are right angles. Now, we get it in our head that a rectangle has two long sides and two short sides, but that's not necessarily true. The definition of a rectangle is it has four right angles. A quadrilateral is a rectangle if and only if, remember IFF is if and only if, it has four right angles. A quadrilateral is a rhombus if and only if it has four congruent sides. Now, what about a square? A quadrilateral is a square if and only if it has four congruent sides and four congruent angles. So it is a rectangle and a rhombus. When you were little in preschool, you probably learned that's a rectangle, that is a square. But in truth, that is also a rectangle, that is also a rhombus. A square is all three. So in your book, they have a Venn diagram. And out here, they have all the parallelograms that could be anything. And then in the Venn diagram, they have ones that have four equal sides or rhombuses, and then on the other side, ones that have four right angles or rectangles. And in the middle of the Venn diagram is the square because it is a parallelogram, it is a rhombus, and it's a rectangle. A square is everything, which I can't think of Venn diagrams without Dr. Diffenschmerz. And here, Perry the Platypus, is my Venn diagram. All right, so here, this is a rhombus, and we need to solve for y. Well, if it's a rhombus, we know these two equations are equal to each other, and we can set them equal to each other to solve for y. So I wrote 5y minus 6 equals 2y plus 3. And then I need to just solve for y. And the first thing I need to do is get all my y's together. And when we do that, we sing the Gathering Up the Term song. Gathering up your terms, stowing away the time. Okay, so I moved the little number to the big one because I'm lazy. You can do it the other way. This is just easier. So I did negative minus 2 to both sides. These cancel out. And 5y minus 2y is 3y. Bring down what you didn't mess with, the negative 6, the equals, and the 3. Now y is y not alone. Well, it's got a 3 and a 6. You always work from what's further away from y to what's closer. So we're getting rid of the minus 6 first. The opposite of minus 6 is plus 6. What you do to one side, you do to the other. Those 6's cancel out. You bring down what you didn't mess with, the 3y and the equal, and 3 plus 6 is 9. Now y is y not alone. It's being multiplied by 3, so we do the opposite. We divide by 3. What we do to one side, we do to the other. Those cancel out. 9 divided by 3 is 3. Ta-da! We did it. Good algebra practice. Okay, here's another one. A parallelogram is a rhombus also if and only if diagonals are perpendicular. So here's my rhombus. Those sides are all equal. I did diagonals, and notice I did way better than usual because it really does look like a right angle. Yay, go me. All right, also, a parallelogram is a rhombus if and only if diagonals bisect the pair of opposite angles. So this one's not quite as good, but pretend. When we draw our diagonals, they cut the opposite angles in half. So this angle equals that angle, this angle equals that angle, and they're cut in half, so this angle equals this one and that one and that one. Those four are the same, and those four, we'll give them 2 dots. Those four are the same. All right? And then here's our last one. A parallelogram is a rectangle if and only if diagonals are congruent. So this is the one situation where you cut them in half and they equal each other. This equals this, this equals this, and they all equal each other because this is a rectangle with those 4 right angles. So would this be true on a square too? Yes, because a square is a rectangle. It's a special rectangle, but if we cut it in half with diagonals, those 4 are equal to each other. All right? You understand? Of course you understand. This is not hard. You've been learning shapes for a long time. All right. Math is great. See you next section.